Okay, this is my animation system, my final deliverable for game 576. And so where to begin? Alright, so previously we had the animation just running on the CPU in the animation controller. And so we were interpolating between the frames in the animation controller classes, and then in the game objects animation we would be updating the worlds and then pushing it to the graphics object. And the graphics object previously was getting the camera's world and getting the inverse bone pose and the current resulting bone world from the interpolated animation between frames. And so the new system, we had to first set up the new shader SSBOs, the shader buffer, or the shader storage buffer objects that is used by the compute shaders. And so this was one of the first little snags that I ran into, because I was actually doing a couple of these steps in the same method. From one of the Chronos demos, they actually had all of this sort of in one method. So there were multiple times where I was trying to bind this, basically set the location for the SSBO, and it kept it was rebinding the data over it, so it was just coming up as garbage data. And so after talking to a couple of the guys in the class, they said that they actually just split it out into its own bind method. So I did that, and then that actually ended up working. And so basically, once we take these SSBOs, this just has the element count, the element size, and then the data that gets passed in to the GPU. And then, so with these SSBOs in the animation controller, I'm actually setting up an SSBO for the 2 frames that are interpolated between, and then the resulting bone positions for that, as well as the results from the second compute shader, which computes the bone worlds times the inverse bone pose. And so I will go through that in a moment. So in setting these up, I had to create my hierarchy table from my converter. So I actually did this in here, and actually I could probably just run this because I actually print out what I did and then I can explain. So that should have already output. So I believe this is for my teddy. Yeah, so what I did is I basically created my table based on each bone, and then I save a space for itself. So I basically take the entire total depth of this table plus 1 so that it has a reference to itself. And then I'm filling this in with the number of bones that I have, because the table is going to be indexed through 0 through 19. And I'm just adding an additional one, and I eventually put an identity matrix into that in the first pass of the compute shader. And so I'm just filling this with 20s, and then same with humanoid, I would be filling it with the 80s instead of some other random value, because we need some way to basically fill that up without it being corrupted data. And so that was sort of the easiest pass that I did. So once I wrote out this table, it's just an array of ints. And then in the engine, I guess I can go through my first pass of the compute shader. So basically, I factored out, this is where I had my frame interpolation methods. So I basically split it out into just one that uses the CPU side, and then one where I'm actually passing everything to the compute shader. And so in here is where I'm actually setting up these uniforms. I pass in the calculated T, and I think I calculated that before. Yeah, So I calculated that before, and then I just simply passed that to the Blender. And I wanted to set it up this way so that I could eventually use it on blending two different animation clips, but I did not get around to implementing that feature. But in the future, I can get to that. It's already kind of set up for that. So basically, I just find that first compute shader and set it to active, and I know the bone count. So the caveat here is when I actually set up the result bone positions, SSBO, I'm actually making it one index higher. That way it's going to be the bone count plus 1, so that I can have 0 through 19 plus the additional one for the array at, in this case for Teddy, it would be 20. So that's where that identity would live. So that is the reasoning for that. And essentially what I'm doing is I do a mod with the group size because the Teddy's 20 and the humanoid has 80 bones. So if I just mod that, and that's how wide my work group would be. So when I dispatch that, the first shader, if I go into here, the compute shader, is essentially where I had to take a couple of our math operations and bring them into here. And so that was basically how I reconstructed the matrices, and I wrote those out. So I did the calculations on the shader, and then I just write those out into the resulting array. So I couldn't think of a better way to do this, but I'm basically slamming in this identity every loop for this, which doesn't seem very efficient, but that's how I'm basically setting it in the index plus 1 position that I'd mentioned earlier. So then once that gets passed to the animation object, this is important to basically, this memory barrier is going to block waiting so that the compute shader doesn't start running the next set of calculations before this is done. So then basically once we have that, the matrices calculated, it passes on to the second set for the compute shader, and in here I basically am getting the position of this skeleton, and in the game I had this set up where I can basically just pass along the position and the rotation for X, Y, or Z, and it'll adjust it, and then inside the rigid objects update, that's how I can maneuver the skeleton around the world. And so I'm actually instancing 2 humanoid skeletons and 2 teddies. And so I scaled down one of the teddies and I moved the objects around so you'll see them independently being skinned. And you can position them and scale them and rotate them independent of each other. So if we go back to here, yeah, so I pass in this hierarchy as this series of ints, and then I pass in the results from the first compute shader, as well as the inverse bone poses that we had previously, and that was being calculated on the vertex shader before. So then inside the second compute shader, this is essentially doing the calculation of the concatenated inverses with the bone worlds, and then that rigid game object rigid position. And so this basically starts out with an identity and then will multiply itself with this up the table. So basically in here, it's going to multiply column by column for each one of these bones, and then it's going to store that back into the array, and that's the world out. And so then the small change we had to do in the graphics object for skinning was I basically just had to comment out so I basically had to comment out these 2 lines because those are being done in the compute shader, and then I just had to create another SSBO for that resulting array of matrices and just pass that into the vertex shader. So then if I go into the vertex shader for skinning, skin vertex shader, I just had to set up this as a new layout, and then I pass that in. So this was the original equation, and then I just commented that out, and so this is the resulting equation that we were doing. So I can go ahead and run this. This is going to take forever to build because it's going to build all my libraries. And we will see the GPU skinning. So one huge issue I had that caused me a lot of trouble and wasted a lot of my time was the alignment issue I was having when I wrote out the hierarchy table, because originally I just packaged it in with the skeleton data, and I guess however I was packing the data in, it was throwing an alignment issue, but it took me forever to figure out that it was the actual SPU file that was causing the issue. So I basically just split that out, and it was a pretty quick change once I found it, but I basically just split that out into its own bin file. Right about here. And so once I did that, the alignment issue finally went away, and I had successful skinning. So I scaled up the first teddy and I shrunk down the other one, and then I have these two humanoid objects. So I could still do everything I did before, or I can swap between the different clips. So technically I could do all these on their own different time, but just for sake of ease of doing the input, I just have them all being changed at the same time. But if I did set different key presses to different objects, I would be able to swap those independently as well. So we can speed this up and rewind it just like before, pause, change clips over, pause, resume. So yeah, that is GPU skinning. So unfortunately I did not get to compression or blending. I'm going to dig into that this summer actually, because I want to get that working. But this was exciting because I was afraid that I was not going to actually get this done because I had so many issues, but actually the debugging of the compute shaders was really helpful. I basically just put a trace out on the where it throws the buffer error in the shader, and that helped a ton. So where did I have that? I had that in shader. So essentially where we're throwing that error right here, I just put another trace outline and was reading that, and that helped me fix a lot of my errors. And so one other issue I ran into was that I kept rendering this and there was nothing on screen. So how I debugged that was a pain in the butt because everything compiled and everything ran, but my issue was that in my animation I was actually binding one of these at the wrong index because I just copied it from the first pass, and so I forgot to change the number, so it was everything looked okay, but it was obviously not running right, and that was not fun. And then the other thing I did was Matt Feingold talked me through this one and basically debug the print of what was in what gets returned from the compute shader. So when I was having issues initially, I basically just printed out everything that was getting passed into the compute shader, and then in the result bone positions, this is the output, so I would basically run that output and see that I was actually getting those matrices. So that was extremely helpful on both of these. Um, yeah, so I'm actually really happy with where I got it. It forced me to clean up my animation controllers because they were basically hard coded to be for only humanoid or only Teddy, not both at once. And I could only have one skeleton on screen at a time, so this forced me to really clean it up and be able to instance each of those, so I could put as many as I wanted in here, and they all are running on their own time controller inside their own animation controller. So that was a much cleaner setup than what I had initially. Yeah.